Hello and welcome to Quantitative Technique videos at edupediaworld.com, your favorite portal for online education. Continuing with time series analysis, today we shall take up the next method of finding the mathematical trend, and this is the calculation of the trend by the least square method. Least square method will be using the linear trend, and we'll see first what this method is all about. We'll see its working, we'll find the derivation, and then finally we'll move on and solve a couple of problems. Alright, so here we go. Let's begin with the understanding of what mathematical trend is. The method of mathematical trend to given time series data is perhaps the most popular and the most satisfactory method of finding the trend. The fitted trend using this method is termed as the best. As I said, it's the most popular and satisfactory. It's also the best in the sense that the sum of the squares of the deviation of observations from it are minimized. That is, the sum of the squares of the deviations of the observations from this particular trend line are the minimum. Okay, so here we use a mathematical equation to determine the trend value. This mathematical equation could be anything, but since we are dealing with linear trend, we will be using the linear equation, that is the equation of a straight line. Usually the form of the equation depends upon the broad idea and the nature of the trend. As I said, we can also fit apart from the linear trend, we can also fit non-linear trends of, say, parabolic and exponential type. And how do we understand this? We basically first obtain the graphical representation of the data, and we understand which of these would be most suitable in our case of the data. Okay, the trend, as I said, could be linear, parabolic, exponential, and so on. Since we are going to use only the linear trend, we'll be using the equation of a straight line. The general equation of straight line we know is y equals a plus b x. Here we'll be using y equals a plus b t, where t represents the time. We'll also be using the subscript t here in y, in place of y. Y is actually a variable for which we'll be calculating the trend value. So this t represents the time. Okay, and yt is the trend value of the variable at the time t, and a and b are the constants. You know that a is the value of the trend, that is would be the value of the variable yt when the time is 0, that is at the beginning, and b is the change in the value of yt per unit change in time. So we know it's the slope or rate of change of the variable. Fine. Since we are going to use only the linear trend, the rate of change of yt is always going to be constant. As is the case, we know that the slope remains the same for a linear equation or for a linear or for a straight line. Okay, so now let's move on and let's see how to calculate or how to determine the formula or the method to find the trend using the method of least square. We'll be given with the data of the variable y and the time t. Okay, what we need to find is the value of the two constants a and b. What we will do is we will assume another variable x. This again, x is time, and we'll be taking x as t, that is the time value minus a. So what basically we're doing here is we are changing the year of origin. Okay, when we take x equals t minus a is an artificial mean, as if you remember we did in the arithmetic mean, we used to take, to shift the origin, we used to take an artificial value. So here we will have x equals t minus a, and this should be taken in such a manner that the sum of the values of x would be equal to 0. We'll see how this would benefit us when we derive the formula. Okay, so here a is denoted, it will denote the year of origin. So let's see and understand how we can go about doing this. Let's say we have the variable, we have the value of t and the variable y given to us. Okay, say t1, t2 up to time period tn, and we have the values of y as y1, y2, so on up to the last value of last time period, that is yn. So here what we do is we'll first take a value a. A will correspond to the middle of the time interval. Okay, it will be in the middle of the time interval. We will take a variable x such that when we subtract from the value of a from t, we'll get the value of x. So we'll write in the next column, we'll have our x. Now the first values, all those before a, would be negative. Okay, then we have the value corresponding to a, and the value here would be positive. We should take the value of a in such a manner that the positives and the negatives balance each other, and as a result we get the sum of the values of x as 0. This is important. Okay, you should have the sum of the values of x as 0. Okay, so now coming to the equation, we have y equals a plus b t. We have now converted that, we have taken a new variable as x, so we will have y equals a plus b x as our new equation when we take x equals t minus a. Let me call this as my first equation. Now let's take summation over equation 1. When we take summation over equation 1, we will have sum of y equals sum of a constant a will be n times a. When you add a, it will sum up as the number of times the value is repeated, plus here the constant will come out, b times sum of x. Let me call this as equation number 2. Okay, once we take the summation over this, we will have here, and now if we modify this equation or rearrange this equation a little, we'll see we will have summation of y equals n times a, and this part, since the summation of x, you see here summation of x is 0, when that is applied, the whole of this part would become 0. Alright, so we'll have this part 0, and we'll just be left out with summation of y equals n times a, and then I can find the value of a from this summation of y divided by n. Okay, that will be the formula to find. I can easily find the sum of y by taking the sum over this column, right? Summation of y. Summation of y by the number of times we have, n is the number of data or number of observations. Fine. So from here we get the value of a. Similarly, now let's take your equation number 1, and this time multiply it by x, and then take sum over it. Multiply equation 1 by x and take summation over it. So when we multiply the equation with x, we will have x multiplied by y equals a times x plus b times x square. Let me call this as my equation number 3. Now if I take, or let me take summation over it first, and then we will call the equation as equation number 3. So when we take summation of this, we'll have summation xy equals a times summation x plus b times summation x square, and this would be called as our equation number 3. Once again, if you look at the equation carefully, you see that we have a summation of x here in between, and again by this what we had done previously, that is by taking the summation of x as 0, we will have this value as 0. Okay, so once again we have this part, the part with a gone because summation of x is appearing here and that's equal to 0. We are left out with the remaining equation, and once we rearrange this, we will have summation xy equals b times summation x square. From this we can find the value of b, and that would be equal to summation xy divided by summation x square. Okay, so that is the equation, or that is the formula to find b. Alright, so here we have both the constants a and b, and we can find easily the values of both of these. The summary of the formula is what we have here. So using the least square method, when you take summation over the first equation, that is the equation of the straight line, and when you multiply and take summation, both of these, after rearranging, will give you the value of both the constants a and b, and these are the formula to find the values of a and b. Okay, so now let's move and let's take the numerical problems. But before taking up the numerical problem, one important note here is that once the values of a and b are found, the fitted line of trend is given by the equation yt equals a plus bx, where we will use both a and b as what we got previously. And since we have changed the time or the origin of time, previously it was t, now we have it as x, we will have to incorporate some important information along with the trend equation. That is, when we write the trend equation, we will also have to provide the following information for any trend equation, and these are the year of origin, okay, the unit of x, and finally the nature of y. Alright, so when we take a numerical problem, you'll understand how do we write the solution and how we incorporate these information into the final answer. Okay, so now let's take the merits and demerits. The first merit or the first benefit of this method is that it is an objective method. Unlike the previous methods, most of the methods which we saw in the beginning were subjective, where the answers would be different for different when solved by different people for the same set of variable. But here in this case, this is an objective method. Anyone's taking up a numerical problem, a same numerical problem will give the same answer. Okay, next, it is possible to calculate the trend values for all the periods, unlike the moving average method, where we saw that there was some data or some observations missing both in the beginning as well as at the end. So here it's possible to compute the trend values for all the periods and predict the values for a period even lying outside the observed data. Further, the result of the method of least squares are most satisfactory. Why? Because it satisfies the properties. The first one is the sum of the variation from the value, that is the observed value. The sum of the variation from the trend value and the observed value would be 0, and the square of the sum from the trend would be minimum. And this is the reason why it's supposedly the best or the most satisfactory method of finding the trend. Okay, and there are some of the some demerits also, like for example, compared to the previous methods, this is cumbersome. We have lots of mathematical calculations, we have a table, we have to do we have a formula to derive and so on. Further, it's not flexible like the moving average method. If some new observations are added at the end, the entire calculation has to be done once again. We cannot continue with what we had previously, unlike what the treatment in the moving average method, where new values were just to be computed separately and incorporated into the problem. further, it can predict or estimate values only if only in the immediate future or past. We cannot go beyond certain values because the trend might change in a separate time zone. So it's valid only in the given time zone. Finally, the computation of trend values on the basis of this method doesn't take into account the other components of a time series, and hence they are not very reliable. And the last one is that since the choice of a particular trend is arbitrary, the method is not strictly objective. Here we can say that since we have different ways of finding the trend, it could be linear, it could be non-linear, and the choice of finding which particular trend it is arbitrary, and so in that sense we can say that the method is not very strictly objective. Alright, so these are some of the demerits of this method. We shall take up a few problems and then we will close this session. Alright, so here is our first problem where we have 7 years data of the profit given in millions. Now here we see that the number of observations are odd, and let me tell you that the treatment of odd number of data and even number of data is different, and that is why we'll be taking two problems. First, we will take up the case of odd number of observations, and then we will move on and take the next problem where we will have even number of observations. Fine. So now here first we need to find the value of x, right? And x, as I had told you, is the difference between the time, that is the first column here, and the year of origin, which we will have to define by the variable a. We will have to select the value of a, and if you remember, the sum of the x I told you should be equal to 0. To make this equal to 0, we will have to pick exactly the one in the middle, and since here we have odd number 7 data, we can directly pick our middle value, which is 2004, and that's gonna be our value of the origin a. Okay, so we're shifting the origin to the year 2004 instead of 2001, and that the data of or the time corresponding to that shift would be now defined under this column under x. Okay, so here we will have 2001 minus 2004. Next we will have 2002 minus 2004, and that will go on till the end. And here now we have the values of x. If you look at this, we have 3 plus 2 5 plus 1 6, and again you have three negative numbers, 3 2 5 and 1 6. So 6 minus 6 is obviously going to be 0. Next, I need to find the value of x multiplied by y. If you recall the formula of a and b, a we saw is summation of y over n, the number of observations, and b is summation of x into y divided by summation x square. So I need x into y, and I need x raised to power 2, x square. Okay, so x into y would be the product of this value here under y and x. Similarly, x square would be the square of the number here. Okay, so now let me drag this to the last cell, and here we have the values of xy and x square. Now let me find the sums of all of these. Total sum, of course we don't need it for t because we're not using t in our calculation. Here the sum of y, we need it. So sum of y is 532, and then when I move on, sum of t, x x, y and x square are 136, 0, 136 and 28, and here we see that the condition is met. The sum of x is 0. Okay, so we are now ready with all the data required. We can find the values of a and b straight away. A would be equal to the summation of y, which is this, divided by the number of data n, which in our case is 7. Fine, so that's the value of a, it's 76, and b would be equal to summation of x into y, which is this number, divided by summation of x square, which is this number. So it's 136 by 28, and that happens to be 4.86. So here now we have the values of both a and b, and once we have got the values of a and b, we are ready with our answer. Okay, let me write the trend equation. The trend equation here would be yt to be specific equals a plus b x. Okay, so that will be a is 76 plus b is 4.86 x. And if you recall, I had told you that along with the trend equation we will also have to write the year of origin. So my year of origin, what is the year of origin in our case? Exactly, the year of origin is the middle value which we have here, which is 2004. Okay, so year of origin is 2004 in our case, 2004. What else do we need to write? We need to write the unit of x. Unit of x. X we see gives us the year, and we see it's changing every year. The value of x is changing by 1 unit. See here in 2004 the value of x is 0. In 2005 it's 1. In 2006 it's 2, and so on. So x is changing by 1 unit per year. So the unit of x is 1 year. Okay, so it's 1 year. And finally I need to write the nature of y. So in our case the nature of y is the profit in millions. It's the annual figure of profit in millions. Annual figure of profit in millions. Fine, so this is our final answer. This is the way in which you should write the solution. Alright, but is that the end? Of course it is, but in case if they ask you to find further the values of the trend, we can do that here. The trend values, okay, and the trend values we can find straight away from the equation which we have got. If we can put the equation here, we know the trend value is yt. Let me write it as yt here. Okay, and the equation for yt we have seen is a plus bx, which is 76. 76, let me put 76 plus 4.86 multiplied by x, and the value of x here is this one. .86 into x. That's the value of the trend in the first year, that is in the minus third year, which is for corresponding to 2001. Further, when I drag this down to the remaining cells of this column, I'll get the values of my trend for all the other years. We see that there is slight difference here. The actual value is 60, the trend value is 61, the actual value is 72, the trend value is 66, and so on. If you want, you can even graph it. Okay, so let me just give you a sample graph of this, the actual values and the trend values which we have here. And if I want a graph for this, well, here we have the graph. As usual, the red line represents the trend values, and the the blue one represents the original value given. Okay, so we can also graph. Further, we can also find a value in the near vicinity. Say, for example, if we want the value for 2008, I'll have to make this as 2008 will be the 4th year. Let me do that separately, maybe. Now 2008, if we have to find the value for 2008 for the year 2008, and that would correspond to the 4th year, because see, 2007 is 3rd year and X is changing by 1 unit per year, therefore this will correspond to the 4th year, and the trend value for 2008 would be 95.44. Similarly, if we want it for 2009, the value here will be 5 and the trend value would be 100.3, and so on. So this way we can calculate the values. We can even forecast the values up to a certain time, say maybe in the next 3 or 4 or 5 years, not much beyond it, because that will not be valid for a longer term. The trend or the slope or the rate of change might change after a certain period. Okay, so this is the comprehensive way of solving a question on mathematical trend using the least square method. Let me just explain it to you once again. We have the year and the profit values given. We find the value of X such that the sum of X should be equal to A. We take X equals T minus A, and A is taken so that this condition is met. Thereafter, we complete the table by finding the value of xy and x square, and we take the sums of all of these. We put it in the formula for A and B, and we get that. Thereafter, we write our solution in this way, where we have the equation where y is equal to a plus bx. We write the year of origin, unit of x, and the nature of y, and then if need be, you can also calculate the values, the individual values for each year of the trend, and then finally graph them. If suppose you are asked to forecast the value for maybe 1, 2, or 3 years, you can do that as well here using the same equation. So that is the treatment for odd number of observations. In case if we have even numbers, let's take another question where we have even number of observations. Here we have just 6 observations. Okay, and then we have the value of y given in sales per year in millions. Now to solve this question, first we will again have to take the value of x, but this time we cannot take specifically a middle value, because there is no one single middle term, as the number of values here are even. Therefore we'll have to take the value between 2011 and 2012. Okay, so the value here will be 2011.5. so my x would be equal to t minus 2011.5. okay, and when we do that, we'll not get the values straight away. It's minus 2011.5, Okay, so we have got minus 2.5 but let's first see if we are getting the values as the sum of x is equal to 0. Yeah, so here we have 2.5, 1.5 and 0.5, and the same numbers and positives here, so both positive and negative will cancel out each other and we'll have the sum of the values of x as 0. But then to avoid the decimals, because that will cause confusion in the final calculation when we are taking the squares and other things, we can multiply this whole column with 2 so that we get integers instead of decimals, and then in the next column we can take the value of x. So x would be equal to 2 times this column, and let me call this column as, let's say, d. Okay, so here let me call this as d instead of x, and next column I can multiply the values by 2, so it will be 2 times the value in this column, and now we have integer. Of course the condition wouldn't change because we are multiplying all the values by one number by an integer, therefore the sum of the values of x still remains 0. Further developing the table, we can find the values of x, y and the square of x. Okay, so the value of x multiplied by y would be the product of these two values, column under y and x, and the square would be the square of this number. Okay, let's pull this down to the last value in the table, and now we have the table complete with the values of x, y and x square. Let me take the sums. Sum of y here would be equal to 120. Further, I need the sum of x into y and sum of x square. So the values here are 64 and 70. I can calculate the value of a. A would be summation of y, which is 120, divided by the number of data. This time we have 6, so the value of a is 20, and b would be equal to sum of x multiplied by y, which is 64, divided by the square of x, and b happens to be 0.91. Okay, so you have both the values of a and b ready. Now I can write my equation. The equation this time would be, this was our first question, and the second question, the equation yt equals a plus b x. We have the values of a and b, so yt can be written as 20 plus 0.91x. This is our equation this time. And then of course the additional information, we need to write the year of origin and unit of x. So what is the year of origin here? Year of origin is the value in between 2011 and 2012. So my year of origin is in between 2011 and 2012. Now what basically, when we write the middle of these 2 years, what we mean is it's actually the end of the year 2011 and the beginning of the year 2012. So more specifically, I can write it as the, say, 1st of January 2012, or say 31st of December 2011. Okay, in the same way, when we are writing the whole year as the year of origin, as in the first case, this would mean that it is the middle of the year 2004. Middle of the year 2004 means the 1st of July 2004, or say the end of June 2004. Okay, so this is, we need to be specific, and this is the way we write. So this is our year of origin. Now coming to the unit of X, let's see what's the unit of X. See, X, if we look at X here, X is changing by 2 years. If we move from 2012 to 2013, we see that the value of X has changed from 1 to 3. So X is changing by 2 units in 1 year. Okay, therefore the unit of X would be half a year, half year, right? Half year, because in 1 year it's changing twice, so it's half a year, it would change once. So unit of X would be half year. And the nature of Y is given in the question. Nature of Y in our case here is the annual figure of sales in millions. Alright, so this is the solution for the second question. This is how we write the answer. Okay, further, if you want to find the trend values, we can do that here. Trend values are represented by Y with a subscript small t, and the trend values will have to put the equation in, which is A plus B, which is 0.91 times X. So the trend value for the year 2009 is 15.45, and so on. We can drag it down to all the cells. It's 17.27 in the next, and so on. In the last one, the value is 24.55. Further, if you are asked to say find forecast the values, forecast the values for different years, say forecast for year say 2015. Let me do it for 2015, 16 and 2017. Okay, so the values of X for these years, for 2015 it would be 7. We see here it's 5. For 2004, X is changing every half a year. Therefore, in 1 year it would change by 2 units. We'll add 2 units here, so it will be 7. The next one would be 9. Next one would be 11. Okay, and then I can just take the same formula from here, and my forecast value will be these two. Okay, so these are the final values we have for the forecast of the year 2015, 16 and 17. The same way we can find for other years also. And finally, if you want to get the graph, let's have a look at the graph and see how the graph of this particular set of data is. So we can insert the graph from here. This is the graph. We see that they're very close to each other, the original and the trend values. Further we can also find the fluctuation as we did in the moving average method. Once we have got the values of trend, it's simple to proceed from there on. You can find either the fluctuations, you can get the graph, you can forecast the values, and all that is just a formality. So here we see that the values of the trend are in the red line here, represented by the red line, and the values of the original sales values are given by the blue lines here. We see that there's slight fluctuation here, and you see even the original data, they are very close to each other. Here it's 15, it's 15.45. When it is 17, it's 17.27. It's 20, here it's 19.09. 21, it's 20.91, again very close. So most of the data are very close. So we see that even the original data are, very much linear, almost approximately linear. Well, so that is the treatment of mathematical trend by using the method of least square. In our upcoming sessions, we will see how can we shift the origin of a trend, or how can we convert an annual trend equation into a monthly trend equation. Well, till then, goodbye. Thank you.